Hey everyone, this is your weekly episode of the Zephyr podcast where we talk about all things Zephyr, embedded, other cool embedded news. My name is Benjamin. I am your co-host.
Hey, I'm Fabio, your other co-host.
So, what happened this week, Fabio? Let's talk about some news, I guess. What anything that caught your eye?
Oh yeah, some random news is gonna become a recurring theme of the podcast. So some noise in the Linux on Rust projects. Apparently, it's no longer experimental. What does it mean? I'm not too sure, but basically they said that yeah, it's not an experiment. It's here to stay. The commit was just deleting a paragraph of documentation, my favorite type of commit. So
Oh,
yeah,
mine too.
oh yeah, less stuff to maintain. Yeah, so it's here to stay. Zephyr had support for Rust for a while, made quite a bit of noise when it got introduced. I'm curious to see projects. So if you have a project that that is written in Rust for Zephyr, yeah, let us know. I wanna see something. I wanna see what you're doing. That's good stuff.
Yeah, well, actually, that you're making me think and reminding me. I need to improve my scripts or be more formal at using GitHub search queries basically to try and
Oh
mine that
yeah,
information. We should be able to do it, right? Like in
remind
GitHub,
so.
you can search by language and by keywords, of course. So that might actually, I haven't tried recently, like just searching for Zephyr and Rust language, see what shows up. Maybe
Yeah.
there will be some homonyms and other non-Zephyr Autos projects, who knows? But probably worth giving it a try. Interestingly, it looks like there was also the first CVE, Linux CVE that has to do with Rust that was
In the
also
same
announced or
week.
unveiled this week. Yeah.
Yeah, it was like a couple of days later. Yeah, Greg announced the same CV related to Rust code. So that was bad timing. But yeah, so I guess it's a good reminder. Just because you're using a memory safe language doesn't mean you're bug free. Obviously, you still need to be defensive. So
Yeah, that was interesting.
that's
All right, I guess usually we start, and I ask you first if you've been working on interesting hardware projects, because that seems to be a thing with you, and that's usually a good excuse to talk about Zephyr drivers and Zephyr features and
yeah.
whatnot. So, have you been working on some cool hardware projects this week?
I have been doing a bit of research for a project, yeah, and the I think it was quite interesting. So I've been avoiding the whole RGB LED madness for a while, and yeah, no, it looks like it's time to do something. So yeah, I'm working on a board that is going to drive a couple of LED strips. So I did some research and some testing, and I figured I would talk about it for a couple of minutes, just to yeah see like explain what I found, because there's some pitfalls when using this stuff. So we're talking about the addressable LED or RGB LED. The two common one are the WS2812, which are commonly known as NeoPixel. I think Adafruit is pushing for the friendly name, and the other one is the APA 102, which I think they are trying to push the name Dot Star as a friendly name. And because what you find on AliExpress commonly is actually a clone of the APA 102, different one, I can't recall the name. So I'm doing a board that is going to be able to drive both. And what's the difference? So the WS are the cheap common one, like you're going to find them everywhere. If you think of addressable LED, that's probably what you're going to find, what you're going to buy. They're really cheap, and it's what you have in your RGB fans, keyboard, all the gaming fancy stuff. What is good about them? They're cheap. What is bad about them? The protocol is a bit of a mess. So you have to control them, sending short pulses on on a pin. The protocol is not very efficient to be implemented on a general purpose MCU. So you have a few options. Like the obvious one is to use a GPIO. The timing are so strict that you need to block the interrupt on the CPU. The risk is that if your CPU starts doing something else, which you're probably going to do if you're using an RTOS, you're going to have a pause that is long enough for the protocol to detect a stop, which means start from the first pixels from the first LED. So you really don't wanna get into that condition by mistake. So what we are gonna do here is you're gonna try to use hardware to drive the protocol, but there's no hardware dedicated for this. So
And the longer the strip, the stricter you need to be with the timings, right? Or
I mean, it's the same timing, right? So you're gonna be impacted potentially whether you have a 2 or a 200 LED strip, unfortunately. So the common approach is to use an SPI port, right? And what we're gonna do is instead you take a byte on the SPI and you use it to send a bit for the device because you have to do a short pulse or a long pulse. So first thing, this is very inefficient. You need to have a bunch of SRAM, and you have if it's a 24-bit RGB thing, you need 24 bytes. So if you have a 200 device strip, that's going to take a lot of RAM. So if you're designing for this, yeah, you need to pick an MCU that has a lot of SRAM. It's a bit of a shame. The alternative is to use the I2S protocol. Same problem. So the good news is that in Zephyr we have a general purpose driver for both configuration. Now there's another problem, is that you still need to clock the data. You need to feed the data on the controller continuously. You can't take a break otherwise. Same problem as before. Like you're gonna see a flash on your device because it's gonna think that you started from net zero. So you need to set up DMA on the device, whether you're using SPI or I2S. And this is where I did some research. So I took some of the boards I have around me and tried to set it up and see how painful it was. And so this is a result. So I had an NXP board, which seemed to have worked out of the box. It's very good. Just set it up. I configured it for a 200 LED strip and looked at the signal on an oscilloscope, and it seems to be shooting out a nice continuous stream of data. That's what you want. Then I tried it on an STM32, and that one was not working out of the box. Like I could see gaps, and for doing this, I modified one of our sample to add a task that would an unpreemptible task that would busy wait sleep for like 300 microseconds. So you would see some proper big gap. I'm thinking about submitting the change because it's very useful. So STM32, yeah, it didn't work, but it was very easy to configure it to work correctly. And actually, this is what I'm going to use in my project. But basically, what you have to do is set up DMA support for the SPI port in device tree. And you have to enable it in kconfig. So it's non-obvious, but there are a couple of examples in the sample. So what I would love to have is more sample for how to set this up. Because it changes.
And then what does that mean? And then the rest of your code, you don't change anything?
Zero changes. This was the very good part about it. Because like setting up DMA can be tricky. And I really didn't have to do anything, right? So Zephyr has a DMA subsystem. We have the WS2812 SPI driver. And you just say, put this value on the LEDs. And if you have the rest of the system set up correctly, which means for STM32 configure DMA support and enable it in device tree, then it just works. So that was really good. I tried the I2S protocol with the STM32, and it did not work because the controller cannot select the bitrate that this protocol needs. I2S is made for audio, and it seems like the STM32 HAL only support audio bitrate, which is annoying. Then I tried it on a Nordic chip, and boy, this is where it got interesting. So I tried it on a 52832, and it worked, but only up to like 20 pixels, 20 devices, sorry. And this is because the DMA controller on this device is limited to 256 bytes. So
Oh, wow. Okay.
Yeah, you know that. So if you use a Nordic chip, use one of the newer one. The 52840 works fine. It's like 65 kilobytes, no problem. And then I tried it on an ESP32C3, very popular. And this one didn't work at all, but it turned out that there was a bug in the SPI driver. It just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 bytes. So it just would skip the DMA configuration if there was only 200 SPI transmit configured and not a Rex. And yeah, that one is fixed. I sent a patch and it's out. So summary, it looks like you can use pretty much everything. Like we achieved portability with this thing. Probably it's a good idea to use SPI if you can. It seems like it's the most tested driver, but yeah, do your test, buy an evaluation board, and see if you can drive all the devices. Like a strip as long as you need with the device.
Maybe a stupid question, but like since this is now becoming sort of like such a popular type of part, like would that make sense for some SoCs to have like a native peripheral for this kind of protocol? Or
yeah, good question. So probably not, because it's a proprietary protocol, but there's a third approach, which is the PIO one, and yeah, it's pretty popular.
What is PIO?
This is a RP Raspberry Pi system on chip.
Programmable IO.
Yeah, programmable IO. Right. Yeah, it's an independent. It's a small core that can execute some snippet of like simple assembly language, and implement Big Bang protocol like this. So it's actually perfect for this kind of application. Now, I didn't try it because I forgot. But I did look at the driver, at the NeoPixel PIO driver. I don't think it's gonna work because it doesn't seem to be fetching the data from the memory buffer directly from the PIO core. It looks to me like it's being fed the bits one by one from the driver running on the general purpose MCU. So I need to give it a go. I think it should be done better. So yeah, that's it. Now the counterpart, the APA 102, that one only works with SPI, and it seems like a bit of a better protocol. Like this is the 4-line device. With the NeoPixel, you only feed the data. The strip is gonna have a 5-volt data and ground. The other one is gonna have clock and data. Same constraint apply, because it still relies on a pause on the bus to reset the protocol. So you still need to use SPI, you still need to have DMA. Yeah. Interesting research. I'll let you know when I make the board if it actually works.
Yeah, that's cool. I guess my takeaway is PIO is really something that I want to look into more, like those drivers that we have in Zephyr or that you can find in the Raspberry Pi SDK and whatnot. Like this is really intriguing. Like you have those Big Bang drivers in like maybe 10 lines of assembly like code, like you just described. That's pretty cool.
Yeah, you should be able to implement some of this stuff efficiently.
Yep. All right. Let's switch gears. Let's look at some of the activity in the GitHub repo and so on. This might be our last episode for the year. What were you doing in 1999? Like there was were you impacted by the bug one way or the other?
Oh yeah, I was absolutely waiting for help break loose in the world. Yeah, it was gonna be over, right? Like I was waiting for my computer to crash.
Nothing happened. Like literally nothing
happened. But
as far as I recall.
But it looks like the Millennium bug is back.
Oh yeah, really?
Yeah, nothing. There was a pull request that was fixing a bug in an RTC driver for 1999, and I thought it was funny. There's really not much to say about it.
We will link to that bug and that pull request in the notes. But yeah, it's always interesting with RTCs. They usually like the century, I guess, flag or register. Some people don't necessarily implement it correctly because they don't care. Like these days, we don't really care about the years 1900 anymore.
I'm not sure where you would bother fixing it, to be honest, but he's right. Why not?
Yeah. Well, you'll never know. And actually, in the kind of like in the same category, there is another class of bug.
Yeah, what were you doing in 2037?
Wait, what? No, there's this other sort of bug that is eventually going to be approaching, and maybe this will be a non-event again, or maybe not. But the year 2038 bug, like sometime in January of 2038, those applications that we're using, only 32-bit representation of for time, and like for seconds elapsed since 1970, they will run out of seconds available. And so effectively, if systems are not using 64-bit time representation, there might be issues. And actually, there were some bad buzz in France, at least, around the fact that the French metro apparently, or at least a good chunk of it, will go on strike, basically, as we do, I guess, in France.
Software strike.
In 2038, because the system, and I think it's a technician that just randomly stumbled upon the bug. They were doing maintenance, and they were trying to input a date like very far from now, and the system wouldn't let them. And they just realized, oh yeah, well, that's why. And then whoever is the supplier, they sort of confirmed that, yeah, there is that bug. But that made me look into how Zephyr deals with that, because quite frankly, Zephyr being embedded, it would be a possibility that, yeah, for efficiency or whatever, we would stick to 32-bit because it's smaller, more efficient, whatever. Except that we are not. We actually have like everywhere our time underscore t implementation relies on 64-bit. And in fact, if you're trying to build with a C library that for whatever reason doesn't use 64-bit representation, then the system will complain, and you will need to try really hard to basically have a bug. You need to disable a kconfig, or rather like enable a kconfig to be like, yeah, okay, I am fine with having time represented in only 32 bits. I know what I'm doing. But yeah, apart from that, you should be pretty, Zephyr is pretty immune to the bug as far as I know.
So if you want an interesting New Year's Eve in 2037, plan to be in Paris, and see if you can still take the metro back to your hotel at midnight.
Yeah. Well, so actually, this is just like random digression. This is not a New Year's Eve thing. Like that one is going to be
randomly
on January the 19th at 3:14 in the morning. So that's like exactly when
you want to
2 million plus 2 billion actually seconds will have elapsed since 1970.
Perfect.
Yeah. What else? Did you pick something from our notes? What did you want to chat about?
Service announcement. The Zskilib, it's up for grabs.
Sigh.
Oh, sorry. What happened?
Yeah, no, that's well. This one, I really hope. Let's take a few minutes to chat about it. But I remember when joining Zephyr a few years back now, there was this library in the ecosystem, which effectively is a Zephyr module, and I think we have also a bunch of code samples. Zskilib is an open source scientific library for embedded system, and to the best of my knowledge, there's not that many others available out there. But like things like it's an embedded friendly set of data structures and functions to manipulate quantities and physical quantities, to do calculations with the proper units, and you want to compute accelerations and do geometry stuff, like you have accelerometers and whatnot. You want to do sometimes like translations, rotations, that kind of stuff. That can be, if you're not that good at math, you will have a hard time. And like I said, also it's hard to make it efficient when it comes to embed. So there's really lots of really nice helpers, and that library has been around for quite a while, and it is effectively, as of today, a so-called external module in Zephyr. Like, we would provide documentation for people to easily pull that into their into their project, but it's effectively unmaintained. So like whatever it has to provide, it's there. It's pretty feature complete in a sense, but it's also true that I think there's been a few pull requests in the past. And like, long story short, if people are interested in helping, making sure that this project is like actively maintained, yeah, do make yourself known. Like join us on Discord, and I mean, have a look, give it a try. Like it's again, like I think it's really cool, and I wish we would be using it more, maybe in some of our samples, etc., because it helps. I mean, you have raw sensor data that you want to like clean up, that you want to provide like a good UI for, and like you do filtering and whatnot. So, yep, that's the scilib, and it's up for grabs, I guess.
Good stuff. We need more maintainers. Talking about maintaining,
yeah, totally.
Yeah. Talking about maintaining code. So if you participated to the process working group, or even just following the discussions that were happening on Discord, this is an interesting one. We're talking about trying to pull approve the pull approve extension for GitHub. So yeah, we'll see. So what's the problem? It's a big project, and it's complicated to maintain. And yeah, we're starting to see some pain from using GitHub as a code review tool. Specifically, the condition about when a pull request is approved, right? Good to be merged. So right now, the criteria is really simple. If you submitted any pull request, you probably experienced it. You need 2 people with triage permission in the org to approve it, and then the pull request is mergeable. Sometimes that's
including the maintainer, like
including the right. So the maintainer thing, yeah, we so that is the basic GitHub stuff, and this is pretty much what you can do with GitHub. Now we added something on top of it. We added this soft layer of extra criteria with it's in a dashboard, right? Like the pull request is mergeable, but we require to have like 2 days in the normal case and the maintainer to have approved it. Otherwise, we won't merge it. But it's like a soft requirement. Like you still have a green button that you can press, which sometimes is useful because sometimes you want to bypass it. Anyway, some pull requests are fine with that. Some pull requests are more complicated with that. For example, if you're adding a new SOC, you're going to add the SOC, the pin control, the GPIO driver, a UART. That's a typical pull request for a new SOC. And we are in the process working group talking about how to handle that, because for such a pull request, you would probably want a person from each affected area to review the pull request. So we're looking into this. Some people are trying this pull approve extension, which unfortunately is a paid extension. So we'll see what's going to happen. But it's an interesting project. It allows you to set a more complex spec of requirement to see when a pull request is approved or not. If you have experience with that, I wasn't able to find a project using it because I want to see how it looks like. I'd love a demo of that. If you have a project, if you know how to use it, good and bad things, yeah, maybe let us know.
Interesting. Yeah, it does look very interesting, for sure. And yeah, it is not free, but I mean, good things are never free. Apparently now, it would appear that for GitHub, and there was an announcement earlier this week, and then it was sort of like reconsidered, but. I think people have seen that piece of news. GitHub was announcing that, oh yeah, from now on, if you guys use the so-called self-hosted runners, which is basically, I mean, you bring your own server, you bring your own compute. Oh yeah, we're going to still charge you for that. And we're going to charge you $0.002 dollars per minute, which is, I mean, okay, not that
hasn't
much.
been received very well.
Yeah, it hasn't. But yeah, so it looks like they might be. I mean, yeah, they are reconsidering this. Which, yeah, I mean, this is an opportunity to mention 2 things. I mean, well, one, in fairness, at least in the original announcement, what they said is that this would remain free for public repos, though. So we wouldn't, like, Zephyr wouldn't have been impacted. But if it had, just an interesting data point, and this is off the top of my head, but I would have I should have double checked, but last month, like during November, if you look at the stats, we effectively used 1.2 million minutes of
Wow.
runtime on our own servers. So yeah, being charged for that would be significant, but it's also like it's really. I mean, for people listening, I mean, obviously that's a lot. That's a lot of compute time, which is great, I guess, to get for free to some extent for you guys as contributors, maintainers, etc. This is resources that the project sort of like offers to the community, but this is also a
CI.
lot. Like this is millions of minutes, and maybe that's too much. I don't know. Like that feels like yes, we have many pull requests, many millions of lines of code, but I would need to look it up. But like, what's the CO2 equivalent of those
Yeah, don't.
minutes? There's a lot
CI is
there.
expensive. CI is very expensive. We could probably do better. We probably should do better. There was some proposal some time ago to try and improve the test plan to run this test because this is hard. There's some situation where we definitely run more tests than we should, and yet on many pull requests we don't run the right test. So it's this is an area that could use improvement in Zephyr. And at the same time, there was some discussion on Discord about running more. Like somebody was asking if we could rerun the CI automatically if when a pull request gets too old, because in the meantime something may have merged in upstream that breaks something, and we were like, he was like, "Oh, it would be nice to have," and I was like, "No, it's not a matter of it's nice or it's not nice. We can't. Basically, we don't have the capacity to do it. Like if we have 1,000 pull requests open. If we start rerunning continuously CI on top of those, like you would never be able to finish a job, to schedule a job.
Yeah, 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 yeah.
Yeah,
But yeah,
big project
1.2
problems.
minutes per month. Yes, yeah. Keep it in mind. Keep it in mind, folks. When like force pushing dozens of times in a row
Oh, I do
and
it all
stuff
the
like that.
time.
Yeah, yes,
It's,
same sometimes, and that's. I mean,
it's
we should
convenient.
think twice.
Yeah.
We should think twice.
All right.
All right. So yeah, that's
Meetings.
yeah, enough with GitHub, I guess. So we should switch to some of the interesting merged stuff, like a couple of new interesting SOCs were added this week. Did you have time to look into them?
Well, I reviewed both of them actually, so I did.
Okay.
I had to have time. So the Realtek AmiBody Plus support is in, and I think that the AmiBody Non Plus support is going to be in soon as well. Yeah, so we touched on this last week. Yeah, it's cool. System on chip with Bluetooth and Wi-Fi. I like it because 5 gigahertz, which is not that common. I'll stop mentioning it when it will become common. So I can't wait. So yeah, it's been merged. Took a while, mainly to get the hull in, but it's in. It's up for grabs. I'm not sure how easy it is to get those chips, but it's certainly nice to have more Wi-Fi chips in. And separately, the Focaltech FT90001 chip got merged. That was fairly smooth. Seems to be somewhat general purpose, though I'm not sure what's used for. And again, I'm not sure how easy to get. But yeah, another ARM SoC in, which is good
Yeah, and
stuff.
in terms of chips with wireless support, there was also like a really cheap, as in I think on AliExpress, you can get them for like $2, and the Saiped MO or M0S dock. So it's like a really small form factor with Wi-Fi 6, Bluetooth 5.2, and that's Buffalo Labs. We see more and more of those being added. So that's
Yeah.
that's quite cool. I guess there's
Many
just
board
we should
as well.
at some point we should stop sort of like mentioning them. There's just so many
So many.
options in there, like $1 to $3 price range. Like just ESP32S3 Geek is another one that got added. Probably not exactly as cheap because it has an LCD display.
But that is
But
very
that's
nice. That is like a USB dongle kind of thing, and it has connector for everything you can want to try. Really, UART. I think it's using the same pinout as the Raspberry Pi Pico Probe. I2C, the classic
right.
quick connector GPIO. So nice board.
Yeah, no, it's great. So I mean, for a while I was, I guess, not complaining, but it was getting slow on the new boards front. But now, yeah, we're back to having quite a lot.
Yeah, a few more.
What else?
Should we talk about it's Zephyr, so we need to announce new macros now, right?
Yeah, well, this one, that was so it hasn't been merged just yet, but that was interesting to see this from Jordan, a new macro. I mean, which is actually meant, I guess, to be used internally, but this might change a few things externally. A macro to approximate heap overhead.
This is a very, very specific one. Apparently, he
It is, but
he he bumped into an issue where he needs to enable heap on one of his downstream project, but he only needs like one struct in. So he had to try. He's optimizing for RAM, right? He doesn't want to waste RAM these days. RAM price anyway. And so yeah, he's introducing this macro so that you can request just enough macro for a specific structure and be as efficient as you can. So this is like a macro to approximate heap overhead.
yeah, because like right now, if you're asking for like I don't know 64 bytes of memory in your heap pool, that's not actually what you get. I think was the problem that it was trying to solve.
Yeah, you have some overhead for what the heap system uses, which can be
Yeah,
tricky. So yeah, this is still in review, and yeah, once it's gonna be in, you're gonna be able to use your heap more efficiently, which is a thing, right? Like things are becoming more and more complex, and we see more and more driver that needs heap to be enabled to work correctly, which is not ideal on embedded because it causes problem if you don't allocate the right amount. Um, One of the tricky thing, by the way, if you're using heap in your project, which you may or may have not bumped into, still talking about macro, are the heap mempool add size underscore something. This is something you may have seen in boards or driver. We have this fancy system where you can define this like a config variable, and then if you try to see who is using it, it's not exactly easy to find out. Like these are macro that are processed by the build system. It's gonna scan through all of the heap mempool, add size underscore anything, and then it's gonna add them during the build and create a new kconfig entry automatically, and then it's all gonna resolve into the single config that drive the size of the main system heap. So
yeah,
yeah,
and this way it should be like really fine tuned and
yeah, this
optimized, as opposed to sort of like guessing whoever is the biggest.
Yeah, and this is
Yeah,
so you can spread the configuration of the amount of heap in various driver, right? For example, you have an existing requirement of heap, and then you enable a new driver. This driver needs more heap. It can set a new config, and they all get added up together. So you don't have to do the math downstream. And with this new one that Jordan is adding, you can do it very precisely. So that's good.
yeah. And speaking of macros, and that's also something that's not anywhere near merged just yet. It's like fresh off the press, but I think this was interesting. A couple new macros being proposed by Peter to do, I think, something that's inspired from the Linux kernel, which is yeah, a couple things. Guarding automatically, like having automatically a block and like some syntactic sugar to some extent when you have something that's guarded by your mutex. Make sure that it's going to get released no matter what when you exit the function. And kind of similarly, you allocate something, you do a kmalloc, and you want to make sure that this is going to get freed up no matter what. So yeah, that's I don't know. Were you familiar with the way this is done in the Linux kernel? Like, is this actually popular, like a popular construct in the kernel?
It is, yeah. It seems like it is. It came in fairly recently, and it looks like they implemented it in many locations. In fact, I'm seeing it a lot on Linux, and we mentioned it a couple of podcasts ago. And
Right.
I don't think it's something that we can use in the core code because I haven't checked, but I suspect it's not supported by some of the proprietary compiler that we need to support in Zephyr. But Picture is proposing to have the macros to use it anyway in Zephyr so that you can use it in the application, which is not a bad idea. The proposal is still out. I think it's a good idea. We'll see what the other guys
And
think.
so the constraint is that this would only work on GCC, possibly LLVM as well.
Definitely LLVM, because people build Linux with LLVM. So yeah, we'll see what's gonna happen. This needs a compiler that support the __ cleanup extension. It might be supported by other ones. I don't know. It seems a fairly esoteric feature, so I'm not sure. But yeah, good picture. I think having it for the application is a good idea, right?
Yeah, and even like so. Well, one that makes the code safer, I guess, but that's also actually genuinely more readable. Like you really, like you don't have to add all those go to, exit, whatever. It's more flows more naturally. So yeah, cool stuff. We'll link to the pull request so that people can chime in, comment. But yeah, it's really fresh, like I said. What else? Well, I guess a couple other. Well, did we want to talk about like just days ago we had a tech talk, a Zephyr tech talk around visual tooling for configuring all things device tree, including pin configuration, etc. This might have been one of the most popular episodes so far. Like it was really lots of, Maxim, the presenter, was sort of spoiling us with like really, really cool tooling and like hardware agnostic tooling for editing device trees. So yeah, people, including myself, really enjoyed it. We will be linking to the replay. There was a question that I think was mentioned somewhere in the comments on LinkedIn, but we didn't get a chance to discuss live. Someone was actually asking like, why is Zephyr using the device tree syntax not something like YAML? I'm not sure there is a
yeah, well, neither of us were part of the conversation. Neither of us were working in the project when this happened. But I don't know. I think that I saw the comment, and one of the arguments I think was that there's not that much carryover from Linux developer, which I don't think is true, to be honest. We see a lot of developer coming from Linux because they work on embedded. They maybe have a project that has both an application processor and an MCU. So I think that the Linux argument actually is a good argument, right? People are familiar with device tree from Linux. That is an argument. Like it was the case for me. Like I use device tree on embedded Linux. A lot of people that use, but everyone who did some ARM recently on Linux is familiar with device tree. But I think that the most important thing is that it's a specific language that has been used for many, many years for defining hardware constraint in an embedded system. If you were to use YAML, you would have to build all of this syntax and validation around it. You wouldn't have been able to leverage existing tools like DTC, which we use as part of the build system in Zephyr to validate the syntax of the tree, even though we don't compile it strictly. So the reason is that it's a very good fit. I understand that if developers have not seen it before, like sure, it's one more language you need to familiarize, and it is a problem in Zephyr because so many languages that are used in the project, right? All the build infrastructure is in CMake. Yep. We have a lot of Python in the thing. The project is obviously C. There's YAML everywhere. We now have linter in Node. Yeah, it's a disaster, but it's a modern, complex project, and you need to use the language that is better suited for the task. And device tree is literally meant for
and I mean, and nowadays, and we've seen that with in another tech talk, I guess. But there's good tooling around it. Like you don't have to necessarily master all the like syntactic specificities of device tree. If you don't have time for that and want to focus on like really your code, then just use some code editors that provide you with code completion, like what Kyle has been working on, the language server protocol and whatnot, or you use the tools that just like we saw in the tech talk this week. It's it's maybe not the best language or like the most modern in a sense. It can be, for
Yeah,
newcomers and people who don't come from Linux, they might find it hard. But yeah, it is what it is. It's a good compromise, I
it's
think.
not that bad. Come on.
It is bad. And actually, maybe for another episode, I will be chatting about some ideas I have to improve the DT doctor thingy.
Yeah.
That's now a thing in Zephyr 4.3, because that's also one aspect. Like you might get your device tree wrong, but maybe, I mean, if you have a good compiler, for the lack of a better word, like if you have a tool that tells you and explains to you what is the mistake you made, and suggests how to fix it, that's also a way to have device tree stop being a problem or a hurdle. That's for this topic. And then I guess just before we wrap up, if you guys want to put a new Zephyr-based device under your Christmas tree, except that it probably won't be delivered by then, but I thought it would be
Next
nice to
Christmas.
mention there is a crowdfunding campaign going on right now on crowd supply for a healthcare related device called the Healthy Pi 6, which, if you look at them, and this is, I mean, the people behind this have been quite active in the Zephyr community for quite a while. And this is, I guess, their new iteration of the device. It is a quote unquote multi-model biosignal research platform that brings professional grade capabilities to academic labs, educational institutions, etc. And it does ECG, PPG, respiration, temperature monitoring, and more, I guess. So it's all Zephyr based. It is open source. I don't know if it is open hardware as well. I don't
Yep.
remember off the top of my head. It
Yeah,
is cool.
they say so.
Yeah, and
Yep.
it is tri-core, as in it's an STM32 with an M4 and an M7, plus an ESP32, I guess, for connectivity aspects, possibly.
Yeah,
But yeah, no, it's really nice.
like lot of stuff there. Like there's an STM32 H5 external RAM, Wi-Fi, Bluetooth connectivity. It's a beast. So good project.
But yeah, no, it is definitely open hardware indeed, like the PCBs and the 3D models, if you want to do 2D printing, I guess, of the enclosure. Pretty cool stuff. You can pledge. You have until January the 22nd. But yeah, maybe that's some kind of Christmas present to yourself. It really feels like a really interesting platform. So Healthy Pi 6. Folks, by the way, if you're listening to us, as always, we very much welcome any tips that you might have and want to send our way, things that you think would be worth mentioning, cool news that you've spotted, new hardware, new articles, etc. Don't forget to like the episode on YouTube, Spotify, whatever. This helps get even more traction. Subscribe as well. And with that, we will be back probably not next week. We may take a small pause, like many of you will probably as well. And we will be back soon for a new episode. Enjoy the break as well, Fabio, and talk later. Bye.
Bye.